So much for joining. I know that a lot of you are just coming out of another session. Thanks, resilience, to go for one more. I decided that the best way to make use of my quarantine is actually to do some GMAT questions, which is a little bit strange, but at the same time, I took the GMAT almost 2 years back now. So it's been fun to brush up some of these things and talk about a few things that worked very well for me. I'm just going to go ahead and quickly do an audio check. Let me know on the comments on the live chat if you can see the screen okay, if my audio is okay, and then we'll just jump right in. Awesome. So it looks like all good. So what I wanted to do today, I'm going to show you guys this one strategy that I used on a daily basis to solve data sufficiency questions. And data sufficiency questions, if you don't know, if you're new to the GMAT, they take up almost 40% of all quant questions. So in quant, you have two types of questions. One is problem solving, and one is data sufficiency. So a data sufficiency question is special because you really don't need to solve the question. You just need to know whether or not you can solve the question, which makes it challenging in some respects, but it also makes it a way for you to get away with less work than a problem solving question. We're going to look at five really difficult data sufficiency questions. These are all official questions, by the way, which is what I would recommend. I do not recommend anything other than official questions, except for questions, for quant questions on GMAT Club. That's the only place where I would make an exception because they're designed by Bunuel, who is a legit legend on GMAT Club. And he makes very GMAT-like questions, slightly harder, and he also has some amazing explanations to those questions. So let's jump into this. Let's just jump into some of the concepts that we will be discussing today. So there are two types of data sufficiency question, and that's it. You will only see these two types of data sufficiency question, and if you can master both of these, you will be in pretty good shape. And what I would push you guys to do is to have a strategy for data sufficiency questions and not go in blind. So what are the two types of data sufficiency question? The first type I'd like to call it a value type question. So the data sufficiency question would end in something like this. What is the value of X? Or how many movies did Souvik watch last week? How many miles did Jamie run? Stuff like that. The other type of data sufficiency question is a yes no question, which is going to be something like, is X greater than 0? Is Y an even number? Is 5 greater than 3? Well, maybe not that, but you know what I mean. So the answer to these questions would be either a yes or a no. So today we are going to look at the yes no type of questions because they end up being a slightly more challenging than the value type questions. A lot of people have a lot of difficulty in these questions, and legitimately so, because some of those questions are really tricky. So I would like to unpack them a little bit and then solve five really challenging questions to put our strategy into practice. So we're going to look at yes, no type questions today. And we're going to start with this question, right? We're going to try to attempt this question first. And while solving this question, I would try to show you guys the strategy that I'm trying to do. All right, so let's look at the question. The question says, a certain list consists of three different numbers. does the median of the three numbers equal the average of the three numbers, right? So right out of the gate, I want to know whether this is a value question or whether this is a yes no question. Does the median equal the average? So this is a yes no type question, because the answer to that is yes, they are equal, or no, they are not equal. Those are the two answers that I am trying to look at while I'm solving this question. So when we look at this question, uh, rather than just going ahead and trying to solve it right now, what I would like to do is to first see how I can attempt to solve it and define my strategy, so to speak. So for this question, for this type of question, my first step would be to frame the actual question. I don't want to write yes or no. What I want to do is to translate that yes and no into an actual mathematical way. So in this case, the yes and no are the median equals average, right? Or the median does not equal the average, right? So those are my only two possibilities. And once I have that set up, once I know that those are my two conditions, I'm going to draw the sufficiency table. So the sufficiency table would look like this, and I want you to do this for every single question. Do not cut corners here, and we will see whether it takes more time or less time, but my guess is it's going to take significantly less if you really follow and trust the process, right? So what do I mean by the sufficiency table? As you can see in the left column, I have the two conditions written down in row 2 and row 3, which is the median equals average and the median does not equal average. And then on the right hand side, I have statement 1, I have statement 2, and I have statement 1 combined with statement 2. And I will try to see whether I can prove or disprove these two statements, right? Does that make sense? Let me know if you have any questions about the sufficiency table before we go right ahead. Okay, so seems like we are good to go. So let me just quickly tell you what I would do with these table, right? So my first step in this one would be to see where my statement 1 is going. So I would try to prove a case for statement 1. Can I use the information in statement 1 to prove that statement 1 is working? Is it sufficient? Can I use the condition in statement 1 to show that statement 1 is valid? If it's valid, I would put a check mark just like this. And then I will try to prove whether statement 1 also satisfies the second condition, which is median not equal to average. And if it does, then I will put another check mark, right? So now if it satisfies both the conditions, that is, if through statement 1, if I can see that, okay, so the median can be equal to average, or the median can also be not equal to average, what does that do to that statement? So in this case, if statement 1 shows that both of these things are valid, that would mean statement 1 is not sufficient. If I can show that only one of them is valid, just like this, if I can show that through statement 1, I can only get one of the conditions, that would mean statement 1 is valid. So if I have two checks like this, that means the statement is not valid. If I have only one check and no crosses, then I would say that statement could be valid. And the final one, I would like to see whether both my statements are valid, right? Okay, so we are going to follow this process for all of them and then try to solve our questions. All right, so let's just jump into that. So this was our question, right? So a certain list consists of three different numbers. Does the median of these three numbers equal the average of the three numbers, right? So the first statement says the range of the three numbers is equal to twice the difference between the greatest number and the median, right? So what do we mean by a range? A range of anything, of a set, means that it's the difference between the greatest number of the set and the smallest number of the set, right? So they're saying that the range of these three numbers is equal to twice the difference between the greatest number and the median, right? So let's try to analyze this statement just a little bit to see what we can do out of that. So I'm just gonna drop in a little text box right here so that we can so that I can show you what it means in this case, right? So let's take these numbers 1, 2, and 3, right? So if I take just these three numbers, because I'm looking at three numbers and three numbers only, so if I look at 1, 2, and 3, then let's see if I can satisfy some of these conditions, right? So this one is saying that the range of these three numbers. So in this case, what is the range? The range is 2, right? So the range of this number is 2 because 3 minus 1, that's 2, is equal to twice the difference between the greatest number, which is 3, and the median in this case, which is 2. So the difference between the greatest number 3 and the median 2, in that case, that is 1. So is 2 is twice of 1? Yes. So then I can say that the median equals average. I have a case for this, so I will put a check mark. Now let's try with another set of numbers, right? So let's try with, for example, 1, 6, and 14, for example. So now the range of this is 13, which is 14 minus 1. And the difference between the largest number and the median, which is 14 minus 6, that is 8. So does my condition hold, that median not equal to average? Yes, but the range is not twice the difference, so I can't use this set. So let's try equally spaced set. I have a feeling that the range will only be twice the median when the set is spaced equally. So let's see something like this: 3, 7, and 7 minus 3 is 4. So I'm going to take 11, which is 7 plus 4, and see what happens. So you'll notice that for this one, the range is 11 minus 3, which is 8. And the difference between 11, which is the biggest number, and the median 7 is 4. So it satisfies the condition of the first statement, right? In that case, is the median, which is 7, equal the average? So what is the average for, so what do I see as the average of these three? So the average is 3 plus 7 plus 11, that is 21, divided by 3, that is 7. So the median again is equal to the average. So I cannot really find a condition where I have no where I don't have median not equaling the average. So is statement 1 sufficient? From the looks of it, yeah, it is sufficient. So I'm going to go ahead and mark that statement 1 is sufficient. So now I have the option between A and D. So now let's look at statement 2. Statement 2 says that sum of the three numbers is equal to 3 times of one of the numbers. So this practically means that all the numbers are equal. If it if it ever says that sum of the three numbers is equal to 3 times of any of those numbers, that has to mean that all these numbers, they are the same. So if all of my numbers are the same, like for example, 6, if I have these numbers like 6, 6, and 6, then the median will definitely be equal to the average. So there is no way that the median will not be equal to the average. So statement 2 is also sufficient. And if statement 1 and statement 2 are individually sufficient, I really don't need to look at the third column. I don't even care about these two, statement 1 plus statement 2. So my answer for this one will be D. Okay, so that's great. I'm getting a few questions. So how can I be sure that there isn't a set not satisfying statement 1? That's a good question. You can only be sure if you try to find a pattern, and we will look at that in the next few questions. We have 4 more questions to go. So let's hold on to it. Hold on to this question, and we will look at it more closely. Okay, so now the so now there is this other thing of looking at what happens when both of these statements are not sufficient. However, I have to look at statement 1 and statement 2. So if I could say that individually neither of these statements are sufficient, but at the same time I will then proceed to look at both of these statements together, right? And then when I look at both of these statements together, and if that condition combined is still not sufficient, then I will move on to my only remaining answer choice, which is C, which is E, which sort of means in this case that neither of these conditions are sufficient. So that's the only option that is left. All right. Okay, awesome. So let me know in the comments if you have a question right now, and then we will move to the next question. All right, so I'm getting a few questions. So Ankit asks, answer is D. How can we say in that statement that the two numbers will always be equal? No, they won't be equal because okay, if you look at the question, just a minute. Let me just quickly go back to the question. So the question says I can only have 3 different numbers, right? So the statement 2, I can only make statement 2 work when all the numbers in the set, all the 3 numbers, they're equal, or the median is the average, right? Which can happen if you take a number set like 1, 2, and 3. In that case, the sum of the numbers, which is 6, is twice one of the numbers, right? So they will be equal when it's twice any of the numbers, but they have to be the average when it's the sum of just one of them. Does that make sense? All right. So I'm getting some audio feedback. Just making sure that you guys can hear me. Yeah, so I think the audio is back on. So okay, perfect. So now we want to look at the next question, right? So this becomes a little bit trickier. So the next question says a and b are integers and b is greater than 0. Does a minus 1 divided by b plus 1 equals a divided by b? So I'm going to use a very similar, the exact same strategy. I'm going to use the same strategy to make sure that I'm trying to drill in how I attempt data sufficiency questions, right? So let's jump into the same format, right? So this is my question. I don't like the a minus 1 divided by b plus 1 equals a divided by b. So I want to simplify it a little bit. And now simplifying it, I want to multiply both sides by b times b plus 1, also called cross multiplication in some places. So in that case, I have AB minus B equals AB plus A. Because B is not equal to 0, I can divide this whole thing by AB. So then what I'm essentially asking is A equals minus B, right? So the question is asking, is A equal to minus B? So now, is this a yes no question? Yeah, it is. So either yes, A equals minus B, or no, A is not equal to minus B, right? Does that make sense? Okay, so then I'm going to proceed as usual. I'm going to draw the sufficiency table, right? So my two conditions in this case are A equals minus B and A is not equal to minus B. All right, awesome. So now the first statement that I have is A equals to B minus 4. So let's look at that statement. So if A equals B minus 4, let's take B as 1, for example, because B has to be greater than 0. If A if B is 1, then A has to be 1 minus 4, so minus 3. So can I say that A not equal to B for this statement? Yeah, I can. So I just proved that I can find A not equals minus B, right? But what happens when B is 2? If B is 2, then A is still greater than 4. If A is greater than 2, then B equals minus B. So I found validity for both of my conditions. So does that mean statement 1 is insufficient? Yeah, absolutely, because I can get both the answers when I use statement 1. So now let's look at statement 2. So statement 2 right out of the bat says A equals minus B. So I definitely find support for this one. But can I ever say A does not equal minus B? No, because the statement already says that A equals minus B. So B is sufficient in this case. So I'm going to go ahead with B. So see what happened here though. If I kept the condition as A minus 1 divided by B plus 1 equals A upon B, this would have been challenging because then I would have to plug in numbers. I would have to see what happens. But because I simplified it at the beginning and made my condition a lot simpler, now I can reduce a lot of time in this question because my precondition is a lot simpler, right? Okay, so we'll jump into the next question. Let me know if you have any questions for this one. Okay, so it seems like we don't have questions for this. That's great because that sort of tells me that we feel good about this. Always know that this strategy will help you doing data sufficiency questions sort of like a mechanical way, which works all the time because it's one of the tried and tested. Because in data sufficiency questions, you are not looking at trying to find out the answer to anything. You're trying to find support for each of these statements, right? So in this case, using this strategy will sort of force you into getting into that mindset, into getting it into a space where you're not looking for answers, but you are looking for support. All right. Okay, so let's jump into the next question. I'm going to give you guys a minute to figure out the conditions and the statements, and then we're going to try to solve this question. Okay, so let's go and try to see how we can use our same strategy for this question. Is the range of the integer 6, 3, y, 4, 5, and x greater than 9? Again, range is the difference between the smallest and the largest integer, right? So this is a yes, no question because either the range is greater than 9 or the range is less than or equal to 9. So I'm going to draw the table one more time, right? And I sort of solved this question beforehand so that I don't waste time writing on this presentation. So let's look at the first statement, right? If you look at the first statement, which says that um, y is greater than 3x. Now, if you take x as 1 and y as 4, because 4 is greater than 3, in that case, the range will be 6, which is the largest integer, minus 1, which is 5, but 5 is less than 9, right? So is the range greater than 9? Um, no, it is not. So I have some support for this statement, right? So the range is less than 9. But if x is 100, right, because y would still be, in that case, still satisfy the condition, uh, then the range will be greater than 9, right? So, so I can find support for both my conditions, which sort of tells me that statement one is definitely not sufficient. Does that make sense? So now let's look at the statement two, which it says y is greater than x and it's greater than 3. So now let's say, for example, let's take x equals 4 and y equals 5 because both of them have to be greater than 3. In that case, the range of this whole set would be the biggest number is 6 and the smallest number is 3. So the range is 3, which is less than 9. So I have support for this one. uh, but at the same time, if I take x equals 100, just like the last time, you want to pick out these extreme cases. If the x is 100, then the range will definitely be greater than 9. So I can support, I can find support for the first condition as well. So now I need to move on to taking both the statements together. If I take both the statements together, I have x is greater than 3. So in that case, because it's an integer, the smallest value that x can take is 4. And now because y is greater than 4 times 3, so 12, so the smallest value that y can take is 13 because they're all integers. So in that case, the smallest value of the range is 13 minus 3, which is 10. So that is greater than 9. So I can find support for this. And because that is the smallest value, I can't take anything less than that. Can I find a range that is less than or equal to 9? No. So only when you combine statement 1 and 2 together, only in that case, I will find sufficiency. So using this table helps you to be on track. The biggest problem that data sufficiency has is the fact that in the middle of the question, you will forget what happened with statement 1, what happened with statement 2, unless you're extremely organized. And this method sort of forces you to stay on track and forces you to be organized. All right. So this was a slightly tricky question. Let me know if you have questions. All right, so we can move on to the next question. We have two more questions left, right? We're going to use the same exact strategy, right? So the question 4 says material A costs $3 per kilogram and material B costs $5 per kilogram. If 10 kilograms of material K consists of X kilograms of material A and Y kilograms of material B, is X greater than Y, right? Again, I'm going to use the same exact strategy, right? Is it a yes no question? Yes, it is. Either X is greater than Y or X is less than or equal to Y. So I'm going to draw the sufficiency table again, right? So let's see what happens when I use the sufficiency table. The first statement says y is greater than 4. But before we get into all of that, let's see what happens when you mix these two materials. So material A costs $3 per kg. Material B costs $5 per kg, right? So if I mix these two, the price of the resultant mixture will have to lie between 3 and 5. Do you agree with that statement? Let me know in the comments. So if I mix two materials of $3 and $5 prices per kilogram, the resultant price of the mixture will definitely be between 3 and 5. Do we agree with that? Okay, it seems we have some agreement. So now, if the price is definitely between 3 and 5, now let's see what happens if I say y is greater than 4, right? So y could be 4.1, right? Y could be 5 kilograms, right? So let's see what happens. If y is greater than 4, right? And I have no limitations of being an integer, right? So y could be 4.1 or y could also be 9 kilograms, correct? So I can make it closer to 5 or closer to 10, right? So what would happen if both of them are 5 kilograms? So I'm mixing exact same amount of material A and exact same amount of material B. If I am mixing the exact same amounts, what would be the resultant price of material K per kilogram? Yeah, it will be $4 per. per kilogram. Exactly. That is totally, totally right. So now if I can show that if y is greater than 4, which is my first statement, right? If I can show that y is 4.1 kilogram and x is 5.9 in that case, then the price would be a lot closer to the price of x than the price of y, right? So in that case, can I have x is greater than y? Yeah, absolutely we can. But because y is greater than 4, y could also be 9, right? Y could be 9 and x could be 1. So can x be less than y? Yeah. So is statement 1 sufficient? Absolutely not, right? What does statement 2 say? The statement 2 says the cost of 10 kilograms of material K is less than 40, right? So the per kilogram cost of material K is less than 4. So now because A is 3 and B is 5, if the resultant mixture is less than 4, that tells me that I have mixed more material A than material B. So that means x has to be greater than y. So I definitely have support. Can it mean x is less than y? No. If x is less than y, then the material cost will be more than 40. If x is equal to y, then the material cost will be exactly equal to 40. So can I find support for x is less than or equal to y? No. So statement 2 in this case is sufficient. All right. So that's pretty much it for this one. So I'm getting a question. Why is the reference to price needed for proving that statement 1 is insufficient? It's given that x plus y equals 10. Doesn't that by itself insufficient? Yeah. Absolutely it is. So we need to get into the pricing because that's what the question is. So if you want to look at it from the pricing standpoint, it's good to think about it this way. But if you want to think about it algebraically, then yeah, absolutely you can. All right, so because I have already proven that statement 2 by itself is sufficient and statement 1 by itself is insufficient, I don't need to even go to statement 1 plus statement 2. That is not necessary at all, right? So I'm going to move to the next question, right? So the next question is going to be slightly tricky for some of you. Maybe this question will be pretty easy for some others. So we're going to look at the last question of the day. So the question says, if xy is not equal to 0, is x cubed plus y cubed greater than 0, right? Is it a yes no question? Yeah, absolutely it is. It's either greater than 0 or it's less or equal to 0. So the two statements are x plus y greater than 0. The second one is xy greater than 0. So let's jump into it. Again, it's a yes no question. I'm going to draw the sufficiency table again. The first statement says x plus y greater than 0, right? So if x plus y greater than 0, what does that mean? That means that either both of them are positive numbers, right? Or one of them is more positive than the other negative number, right? For example, x could be 1 and y could be 0. Or sorry, y cannot be 0 because xy not equal 0. So x could be 1 and y could be 2, right? In that case, x plus y is greater than 0 because x plus y is 3. Is x cubed plus y cubed greater than 0? Yeah, absolutely it is. So I have some support for x cubed plus y cubed greater than 0. So I'm going to put a check mark. Now let's look at the second one. If x plus y greater than 0, can x be negative 2 and can y be 3? If x is negative 2 and y is 3, then is x cubed plus y cubed greater than 0? Yeah, because 8 minus 8 plus 27 is greater than 0. So I cannot find support for this one, right? Because in no way, if x plus y greater than 0, then x cubed plus y cubed will be less than 0. because one of these numbers by its absolute value will have to be bigger, right? So now let's look at statement two. Statement two says xy is greater than 0. It basically says that either both of them are positive, right? Or both of them are negative. So let's see, if both of them are positive, then is x cubed plus y cubed greater than 0? Yeah, it is. If both of them are negative, then is x cubed plus y cubed greater than 0? No, it's absolutely not. For example, if x is -1 and y is -2, then x cubed plus y cubed is less than 0. So is statement two sufficient? No, it's not, because I'm finding support for both my conditions, right? So statement one, definitely sufficient. Statement two, definitely insufficient, right? Okay, so let me know if you have any questions for this one. It seems like this was slightly easier because I think because of cubes, cubes follow the same signs as the original numbers, unlike squares. So that makes it a slightly bit more easier. Okay, so what I want you to do today is go to GMAT Club and try to find questions like these, yes, no type questions, which sort of does the same thing, and try to use this data sufficiency table and use it in a way where it makes your life easier, helps you be more organized, right? Okay, so thank you so much for joining. By the way, just so you guys know, tomorrow I am, by the way, I'm a second year MBA student at the University of Michigan Law School of Business. I'm just finishing my MBA and I'm graduating. So tomorrow, the same time, we are doing a mock interview for a mock case interview for a tech product management role. So we are going to look at how companies like Google, Facebook, Microsoft, Amazon, how they interview using the case method. We are going to take on a popular case question, and one of my MBA peers is going to interview me, then give me feedback. We'll try to make sure that we have a few ways to teach you guys some of the skills that we have used to crack some of the MBA interviews. So stay tuned for that. Join me tomorrow. Thank you so much for joining today, and I'll see you guys tomorrow.